Welcome to another screencast. Today we're going to discuss how do we locate the epicenter of an earthquake. And so if you knew that if you have a seismograph station and you knew that the epicenter was a certain distance away from you, but you didn't know direction, what geometric shape would you use to draw on the map to symbolize that distance from the seismograph station? Would you use a square, triangle, a star, or a circle? Well, the correct answer, we'll use blue, I guess, we would check and say the circle would do that. So if you have a town, and that town in this case is Niftyville, and it's very nifty in Niftyville, and in Niftyville you have seismograph stations. You have seismograph station X, Y, and Z. So if you know that there was an earthquake and you get the data from seismograph station X, you could find the distance by using the difference between the arrival of the P wave, primary wave, which arrives first, and the S wave, and using the reference table you could find the distance. You would then use the scale of the map with your compass, which we'll talk about a little bit later on, put in that scale into here. Here's your pivot point, and then you would draw your circle showing that the epicenter could be anywhere along this circle around seismograph station X. If you use the data from Y and X and Y together, you can see that you have two options for your epicenter. It could be at either point where the two circles intersect. So it narrows it down somewhat but doesn't give you the exact location. Not until you get the data from seismograph station Z can you then definitively say that here is the epicenter of the earthquake. So the minimum number of seismograph stations needed to pinpoint the location of an epicenter is 3. So if you look at the parts of a safety compass, which is so much nicer than the unsafe compasses we used to use, you can see that there's a pivot point. That's where you put your finger on. And then you have pencil points and pencil holes. To put your pencil point in, you get to choose, which is a very exciting time. And then it's tough to see on this, but there are arrows that exist there. So using this page in the reference table, difference in arrival times between the P wave and the S wave that you would get from seismograph data, and we kind of used this sheet in the last screencast. And let's say if I use Seattle as an example, I'm only going to do one example, so don't cry when I'm done. And if I were to take a look and see that Seattle is 1,000 kilometers away from the epicenter, and I'm going to switch now to the map over here. So what I'm going to do is I'm going to get out a full screen here so I could go to the map. And now here I have my map, and you can see that Seattle's over here. I have my scale over here. I'm going to take out my safety compass, which is going to make an appearance. So you might see a drop in volume. That's because I just got far away from it. So there's my safety compass. What I can do is I can put this, and there's a couple ways to do it. You could put the pivot on the 0 and then move this till the pencil hole is at 1,000 kilometers. That's what some people like to do. You can also, if you notice that this 0 or the pivot mark is lined up with the line, that's also 0 centimeters. I can do that, and then I can move this till the arrow is on the 1,000. I could also go above too so that I could see the scale a little bit easier, right? And then you can see that I can move till my arrow is pointing on the 1,000 kilometers. Now I know that that is 1,000 kilometers away. It will be capable of drawing a circle 1,000 kilometers away. So now if I bring this back over to here, I bring this to Seattle, and I line that up, you can see that the pivot is on the dot of Seattle. Right? And now I put my finger over the pivot point, I put my pencil in the appropriate pencil hole, and then I just make my circle. I have a little obstacle in the way there, and it just takes a little bit of time. And that, ladies and gentlemen, is showing a circle drawn around at a scale of 1,000 kilometers, and the earthquake epicenter could be anywhere along that point. Obviously, we'd need 2 more circles in order to pinpoint the location. What I generally like to do too afterwards is I like to put it back on, make sure it didn't move, and I can confirm that in fact I still made the circle for 1,000 kilometers. It's just a nice way of double checking your work, and I know we're all a big fan of double checking our work. So that is the basics of drawing circles to symbolize the distance from a city to the location of the epicenter. You'll be doing a lab involving this where you will actually pinpoint the location by using data from 3 different seismograph stations. Enjoy your day.